Hey guys, hoping all is well with everybody. In this video we're going to be continuing on with the Chapter 2 Geology exam review. In this video we're going to be going over the explain questions as well as the application questions. So without further ado, let's look at our first explain question, which is contrast the Earth's three major layers. So remember, our three major layers are going to be the crust, the mantle, and the core. Now, when we contrast something, we're taking two or more objects or ideas and we're finding their differences. So one of the ways that we can differentiate these three layers of the Earth is kind of how their contribution to Earth's mass. So we have the crust, which is extremely thin, and it's about less than 1% of Earth's total mass. Whereas with the mantle, it's going to be about 66-67% of Earth's mass. And then the core is about 33-32% of the Earth's mass. Kind of depends on how you add it up to equal 100%. So that's one way that we can contrast, is just by how much they contribute their layer to Earth's mass. Another way that we can contrast is by how their individual layer has its own characteristics. So the crust itself is made up of solid rock, and it's a very thin layer. The mantle has two parts to it, divided by the transition zone. So it has the upper mantle and the lower mantle. And then the mantle is divided by the core. The lower mantle is divided by the outer core by that core mantle boundary at about 2891, 2,900 kilometers below the surface of the Earth. So we can also kind of make contrasts and differentiations on those as well. We have the transition zone and we have the core mantle boundary, kind of separating how far these layers are from the surface of the Earth. So that crust being the outermost layer, the mantle being the next, and then the core being closest to the center of the Earth in terms of these three layers. Okay? Let's look at the next question. Explain how geologists can gain information about the Earth's interior. So remember, geology is the study of Earth. It's a very general study topic because there's so many subtypes within geology. We have volcanology, the study of volcanoes, which is where people can kind of study volcanoes to kind of predict how whether or not a eruption may occur or what's going on inside of a volcano due to a lot of under the ground events and phenomena are taking place. We have seismologists, which can study earthquakes by using seismographs and certain scales to understand why vibrations are taking place, mainly due to the interaction of plates. Okay, so again, geology is a very general study, and those subtypes of that of the study of Earth really can go into a lot of different categories to figure out what's exactly going on inside of the Earth itself, especially with seismology and volcanology. The next question says, briefly describe the theory of plate tectonics. So again, that was that idea that was in 1859 that said that there were 8 large plates as well as several larger plates that kind of existed and connected and interacted together. And we also, with that idea, had this idea of Pangea being that supercontinent. And over time, the 7 continents came to be through the interaction of these plates, causing a dispersal of the big supercontinent of Pangea. Okay, so that theory of plate tectonics is that there were those 8 large plates and they interacted together along with several smaller plates. Describe or compare a fault and a fold. So a fault is defined as a boundary between stationary rocks and moving rocks that may suddenly form during an earthquake. So, for example, here I have a fault line, and when a earthquake suddenly occurs, there's its focus, and that focus is the point at which an earthquake occurs. And then you have the epicenter, which is the area on the Earth's surface directly above the focus. So a fault, again, is this boundary between stationary and moving rocks that may suddenly form during an earthquake. Folding, on the other hand, is the process by which rocks move into certain shapes based upon the exerted force on them. So when you have a object that has great force being put on it against like an immovable object, that object has to go somewhere. So when we push or give great force to these rocks, they're either going to form a arch-like formation, which is the anticline, and then it can also go into a trough or dip-like formation, which is the syncline. And that's what folding is. It's the formations of rock by either bending or buckling when rocks are under great amounts of force. Okay. How does the elastic rebound theory explain the occurrence of earthquakes? So for this, I want you guys to imagine that you guys have an object. In this case, I have a ruler, but think about it like a yardstick or a rubber band. Any object has elasticity. It has the ability to resist and kind of go against tension. So when I bend this ruler, as you guys can see, it doesn't have a lot of elasticity as much of a rubber band or a yardstick. But the fact still remains, every object still has a limit or threshold that it can be under tension and stress. So, for example, if you have a fence or a rock wall in your yard, and before an earthquake, there's going to be this kind of wanting to stay at the least amount of tension, and it's going to want to spring back to where it's minimizing that stress and tension. So what's going to happen is the rock wall is going to bend, and it's going to bend basically to keep up kind of with that resistance and tension. But as it becomes more and more, it's going to be impossible at some point, because it's going to reach its threshold, that rock wall is just going to snap. And when it snaps, those two parts of the rock wall are going to go to a point where it's the least tensioned or stress put on that rock wall or fence. Okay? And this gives the idea when an earthquake occurs. And after the earthquake, it kind of springs back and goes back to its normal position. But at that point, the damage has been done and it's separated. Okay? What is the difference between a seismograph and a seismogram? A seismograph is the device that is used to measure earthquake intensity and magnitude, where seismographs, or seismograms, is the actual reporting or paper kind of showing the illustration of the mathematical results of a of an earthquake. Okay, so a seismograph, again, is the device that is used to measure the intensity and magnitude of an earthquake, where the seismogram is the actual result or paper that shows the statistical analysis of what the seismograph recorded. Okay. Explain how scientists can classify volcanoes according to volcanic activity. So we have three types of volcano statuses, so to speak. So looking at those, we have active volcanoes, which is where a volcano erupts frequently or often. We have a dormant volcano, which means, kind of remember like college dorms. It's almost like where like sleeping of college students takes place. So it's kind of like, it's not active, but it can erupt again. So it's almost like it's sleeping, catching some Z's. And then extinct volcanoes is one that is classified that it's more than likely not going to erupt again, but because of the way that natural phenomena take place, like volcanoes and earthquakes, we can't say for sure that it won't ever erupt again, just because of all the external stimuli and factors that are on that volcano. Okay. Explain or describe the four types of pyroclasts. So the four types of pyroclasts again are volcanic ash, lapilli, volcanic blocks, and volcanic bombs. So lapilli and volcanic ash are more based on size. Lapilli is 2 to 64 millimeters, where 64 millimeters is about 2.5 inches. And volcanic ash is significantly smaller, where it's less than 2 millimeters, being about 8/100ths of an inch. Okay, so those are based on size. Volcanic blocks are going to be the irregular boulder-like shape ejecta that is out of a volcano. So it's irregular and it's boulder-like in shape. Bombs, however, are going to be the ejecta molten rock lava that comes out, and what happens is it cools and solidifies into rock before it hits the ground. Okay, so with these two, one is irregularly shaped boulder-like molten rock material, and one is where the phenomenon of it being thrown into the air, ejected, and it cools and hardens and solidifies before it hits the ground. Okay. How do dikes and sills form? So looking at this, what we're basically looking at is dikes are going to form when the sheet of rock, or a sheet of rock, is a fracture of pre-existing rock body. So basically, I'm gonna illustrate a dike by it goes in on a slant. It's gonna be more of an intrusion, and it can either be magnetic or sedimentary. Then comparing that to a sill, I think of sills as kind of like windowsills. So they're tabular sheet intrusions between other layers of sedimentary rock or beds of volcanic lava, or even along a foliation of metamorphic rock. So a sill is going to be more of a flat intrusion, whereas a dike is going to be more of an intrusion kind of along a slant in pre-existing rock bodies. Okay? Explain, or could seismologists and volcanologists also be called geologists? Explain your answer. The answer is yes, because if you think about it again, geology is a very general term for a study of the earth. However, there's many subtypes in between. So, because seismologists study earthquakes and volcanologists study volcanoes, and that's a very in-depth, more detailed study within the earth, about earth, you can say that a seismologist and volcanologist are under the umbrella of geology, studying earth itself. Okay, so seismologists and geologists, or seismologists and volcanologists, are just more detailed studies of geology and Earth itself. Okay. Compare and contrast three different methods that seismologists use to determine an earthquake's strength. So we have three types of scales that we can use to determine our earthquake strength. The first is the modified Mercalli scale, which has 12 degrees of intensity, but is based off of observation and experience and kind of what people have felt. Okay, it's not kind of what a seismograph would mathematically read. Going with that, a Richter magnitude scale is a local magnitude scale that rates earthquakes mathematically, more likely numerically, by looking at patterns of a seismograph. So this is going to be a lot more based on numbers rather than actual observation. And then last but not least, we have a moment magnitude scale, which is defined as the most reliable measurement, and it is based off the size of the source, and it measures the size of the source and converts it into a scale similar to the Richter scale. So what I want you to think about here in this kind of scale is it's not just related to earthquakes. It's kind of, it gives you the idea of sources like the atomic bomb intensity, the intensity of a bolt of lightning, the intensity of a volcanic eruption, and these are kind of used relative to an earthquake, and that way we can kind of use point sources, model intensities and magnitudes to determine the strength of an earthquake. Okay. But I hope this video helps you guys out. If you guys have any questions about any of the explain or application questions, we're going to be going over one more in the next video, but I hope you guys enjoyed this video. Thank you so much for watching. Take good care.